So conventional guide. So physician sent ablation catheter and diagnostic catheter to the heart under the X-ray and collect electrical signal from the heart and using with the EP recording system analyze the arrhythmia. We can think like 2D mapping, conventional mapping like paper guide navigation. 3D navigation system is physician sent the catheter to the heart. At the same time, system collects geometry and intracardiac signal from heart and shows us with the colors. So we can easily understand the mechanism of the arrhythmia. We can think like GPRS navigation. What is the technician's role in 3D mapping procedures? So first of all, patient preparation, system preparation, troubleshooting, which is very important, using of the 3D navigation system, clinical team communication, and post-procedure responsibility is technician's role. So what is the soft skills? First of all, technician needs to be focused. When we are performing case, we are searching some small signal. It can be his, which is very important. So we need to focus on the screen and we need to collect the points from the heart correctly. And we need to be adaptable. So during the case, arrhythmia can change or cycle length. Tachycardia cycle length can change. We need to be adaptable. So we need to change our strategy. That's why we need to be focused and be adaptable and calm under the pressure. So during the case, sometimes patients' hemodynamic can change and we can feel under pressure. At that time, we need to be calm and we need to communicate with the physician, and what physician needs us, we can do as soon as possible. So pre-procedure preparation. First of all, before patient came to the lab, we need to make sure that system is installed and tested well. We need to make sure that everything is working. And then we need to check the arrhythmia. We can check the patient's document and we can learn which type of case we will perform. So we can prepare our system according to case type. So when patient came to the lab, first of all, we need to record. So it can be VT case, PAC case, PVC case. When we see, for example, PVC, we need to take a screenshot because during the case, we will use it. So also ensure all the products to be used will be located in the cath lab. So for example, we will perform atrial fibrillation case and we know that physician will use transseptal sheet and needle. So before the case, we need to make sure that all the products are in the cath lab. So we shouldn't waste time for searching where is the product. Patient preparation. For the patient preparation, we are using impedance patches and magnetic patches. So these patch locations are important. We need to have a handbook. We need to know that which location of the patient we need to connect, and according to our handbook, we need to connect the patches. After this patch preparation, system will create magnetic field and we can be able to visualize our ablation and diagnostic catheters on the system. So what is the technical steps? We have two different type of the methods. One of them, we call it LAT, local activation time. Another one, voltage mapping. So local activation time mapping, we choose one reference signal. It can be surface ECG or intracardiac channel. And system compare from our ablation catheter or mapping catheter to reference channel. And if it's early, if ablation, for example, let's say we are using ablation catheter, if ablation catheter signal is earlier than reference, we will see red on the geometry. This means that we are close to the origin of the arrhythmia. And purple means the latest, the farthest point from the origin. This is local activation time mapping. So voltage mapping is different. System check the strength of the signal. So if the signal amplitude is high, we will see purple on the system. This means that tissue is healthy. But if we don't see a big signal, if signal amplitude is low, system will show us red. This means that it can be scar or border zone. This is the voltage mapping. Troubleshooting. So troubleshooting is most important part, because before the case we need to check the system status. We need to make sure that all the parts are working properly. For example, here in this picture we can see patient interface unit, location processor unit, field generator. All of them is green, means working. So error code list, if one of them is red, if means that doesn't work, system will give us one error code. So we need to have a user manual and handbook that we can check which error code means what. So after we learn the problem, we need to have a spare cable that we can change the cable and perform the case. Key takeaway from 3D mapping support. So preparation is key. We need to prepare the patient and system well. This minimizes the risk of the complication. The preparation is the most important thing. The knowledge of the conventional EP and 3D. So first of all, we need to know, as a technician, we need to know that conventional arrhythmia. So if we know that the conventional EP, then 3D will be easier for us. Troubleshooting skills, as I mentioned before, the ability of the read of the error codes will increase the success, and we can directly take an action and solve the problem. We can perform the case without any problem. Thank you.
Thank you very much, Dr. Ahmed. Actually, I see you have briefed most of what we see every day when we are seeking the help of our technicians. The procedure can't be successful without following these steps by the help of the technician. The focus, the working under pressure, when Dr. Mervet is under her extreme pressure for the sake of the patient, but knowing the conventional and knowing the 3D knowledge, knowing the troubleshooting, preparing for your patient with spare parts and if you need any fixing. You briefed it all, but a question for you to make this helpful or a guide for all our colleagues from the technicians and allied professionals to be that much prepared and help in the success of the procedure. What routes of education and routes of competences do you as Microport can give through AFRA or other channels?
We have some trainings for technicians and doctors. Yes, we can give trainings for the what needs. For example, technical steps or EP knowledge. We have 3 different steps for the training: EP fundamental, level 1, level 2. First of all, we are explaining the arrhythmias, and then we are focusing on the system, how to manage the system.
I do have a question. How long does it take for a technician who didn't perform this kind of support to be competent and to be alone in a case like this?
So, my experience, I can say 1 year, but after 1 year, he can perform all type of the cases. But some, for example, conventional cases, the time can be shorter. But 3D a little bit more complicated, that's why it needs more time.
Yeah.
And experience also, need to attend some cases, see how situation.
Yeah, thank you.
I want to add something that conventional ablation is a machine recording intracardiac signals, 12-lead surface ECG, is connected to another stimulator, like the pacemaker we use, temporary pacemaker, but in a special way. You will see this in some pictures coming in next sessions. And to ablator, which delivers the energy of ablation, whatever kind of ablation you are performing. The whole thing is connected to the patient. First of all, you have to know which machine, EP machine, you have in your lab. Which catheters are connected to the ablator and the connections are compatible. The stimulator is connected to which channel. You have to understand technical points in order at the end to get good signals, no interference, good communication between the setup, and then you can do the procedure. Alfie was very intelligent when he joined my team in 2012 to understand every single step as a doctor. And through this, we taught our engineers and technicians to improve the service. If you are in the lab and you are a doctor, you don't think of what is connections, you are lost. Sometimes the ECG, like Siemens EP machine, the whole intracardiac is starting by the surface ECG. And you might not work without this surface ECG. The grounding of the table, the grounding of the whole room. Sometimes if you connect two machines with a splitter, then you get interference. You have to connect each machine alone. The 3D system is another way of understanding electrophysiology. The 3D system is a machine which makes a virtual picture of the heart and the different chambers of the heart. And you teach the machine where you are. The picture will not tell you are in the right atrium or right ventricle. You are the one who are going to map and annotate and build the picture at the end. In order to build good pictures, you have to have this magnetic field or the machines which works with frequency or whatever technology is built in the machine. So these patches should be correctly attached to the patient. The magnet under the table should be in place. Sometimes very obese patients can make problem on tables. So these technical points you are going to learn from the company, the mother company. The MicroPort or Everpace is different from the Carto, is different from the Insight X, is different from the Orion or Rhythmia. So each machine has its own patches, it has its own connections, it has its own mind, brain. And the engineers of this company should be with you from the first step to make sure that the patient is connected, no interference, the magnetic field is okay, and then you do the procedure and you get the success. Thank you, Ahmed, very much.